Okay, I'd like to welcome everybody to final presentation number 6. This is our second to last presentation for the day. We have one last presentation following, and this is being given by group GC34. Good luck and take it away.
Okay, I'm going to share my screen. Okay.
Jana, can you go back to, okay. Okay, good morning. I'm going to introduce my teammate. Her name is Joana Romero, and my name is Canel Prieto. And the title of our work is Prediction of Hamilton Parking Space Occupancy and User Behavior. Okay, next. Okay, here is the packages, the languages that we have used: Python, R, Power BI, and Google Maps API. And the outline is the introduction, the goals, variables description, occupancy prediction, user classification, and we finally conclusions. The introduction: nowadays car parking is one of the main concerns for transport and traffic management around the world. Then it's important to understand user parking choice behavior and actual demand of parking occupancy. There are some recent studies about that, and here we have, in this phase 2, we have focused on 30 parking lots. Here, well, we are going to describe what we call best features to predict occupancy space for those 30 parking lots for these specific years, 2019 to 2021 of these specific months, September and October. Okay. Here are again the goals. Mostly we are focusing here on the top left. We can see a mobile phone. Like mainly, this data was from Passport and Kale apps, and all of our work that we have submitted in both phases, can be implemented as an add-on on a Passport app. In this application would be like, if I go to a specific place, this add-on will display the top closest parking lots with their respective availability. So that's a main goal. What were our variables? There were a mix of 3 kind of variables. This comes from the data set that the organizers have provided us, like the open hours, price per hour, price per hour, and month of year, day of week, is it weekend or not, total duration, which is the sum of the duration time of all the cars which were parked at a specific lot. Then we add those variables. We add these distances to the top closest of the respective these places. Is hospital, banks, restaurants, church, schools, coffee, university, parks, bars, clubs, and so on, using Google Maps, Python, and Google API. And finally, we combine them with socioeconomic variables, which, as you can see, we have used this transport. Here, we have downloaded this survey, which the name is Transportation Tomorrow Survey of Hamilton, specific of the most recent one, which is one from those from 2016. And this data was clean and it was used per ward, with a total of 14 wards. And as you can see, for this specific data set for this phase, the result of using a machine learning algorithm, which is a gradient boosting, was R squared. R squared gives you that the model explains 36% of your variables variances. So that's the meaning of this result, which is a little bit low because the data size is low. And in phase one we got almost 60%, and so we got capacity, day of week, day of month, the distance, top closest distance to a restaurant to charge is weekend is no. The answer is means like 0 is no. Month of year, it corresponds to the September, and distance to park, university, and distance bar. And then there were some important variables like the number of trims by GO rail, number of persons which transit pass from other agency, and the number of houses per ward. Okay. And here I'm showing on the top left, I'm showing from as I have mentioned, this is for 30 parking lots, and here is like okay, they are located in different locations of Hamilton wards. So here we present a summary of the maximum and the minimum values for number of parking lots by location, capacity prices, and number of open hours. The main best features that we got from using machine learning. So, okay, this is the Ottawa Street North, which has 4 lots. Then is Barton Street East, Grosvenor, which has 2. And finally, Bank of Montreal. On the top right, you can see the biggest parking lot, which corresponds to the lot number 40, and which has 35 slots and so on. And then is the prices, in terms of the prices per hour and the prices per all day. And as you can see, here are how is from the maximum to the minimum. And finally, you can see here is the total number, the maximum and minimum open hours. It was 18 and 24. Here is an example of 2B parking lot, which has the capacity 63, and I'm going to describe you the summary, the closest places to this particular parking lot. A restaurant, which is the 0.0881, all are in kilometers, and then a bar, then a church. And so then we can infer that if a user uses this parking lot, it may go one of those 3 places. The furthest was for a hospital. Here is like is for the same parking lot, which as I have mentioned, using this information from Google Maps API, we get the restaurant, which corresponds to the yellow circle, and then a bar, which corresponds to the green one, and so on, the church, school, bank, hospital. And we got the names of those places, the ratings, and the raters, the number of raters. Yeah, so as you can see here, is all of this has been implemented in Power BI as a dashboard. Okay.
Okay, now we are going to show another example for other important parking lot, which is the number 40. Parking lot number 40 is the parking lot with the highest capacity. And this, you can see a summary of the important information about this parking lot. In this graph, we can see that university, school, and restaurant and bar are the nearest places to this parking lot. In the next slide, we can see the names of that places. For instance, the school is Michel de Groot School of Medicine. The name of the restaurant is La Prep. The name of the bank is BDC, and so on. Additionally, in this table, we can see the rating and raters of that places. And additionally, we can access to the website of these important places. It's important to mention that in this dashboard, we not only check the information of the first nearest places, but also for the 5 nearest places to this parking lot, which is one of the most important parking lots in Hamilton City. Now, we are going to talk about the occupancy. In this slide, we can we can see the information of the total occupancy per year for 2019 to 2022. In this pie chart, we can see that 2020 was the year with the highest total occupancy, followed by 2019, and finally 2022. Per month, we can also check that September September had the highest occupancy in comparison to October, and in this color blue, red, and orange, we can check the occupancy per year. Finally, in this bar chart, we can discriminate the occupancy per day. For example, Friday and Tuesday were the day with the highest occupancy in all 30 parking lots under this study, and Sunday and Monday were the day with the lowest occupancy in the 30 parking lots under this study. For this analysis, we can infer that parking lots were used most for study, for universities, for bank, and not for weekends. Finally, we can see here the time series for parking lot number 40 per day for the year with the highest occupancy and the month with the highest occupancy. We can see here, for instance, in Monday, where the highest occupancy, and Sunday had the lowest occupancy. Finally, we are going to show a classification of users for 2020 and 2021. For instance, the parking lot number 8 has the highest duration and has the highest one of the highest user frequency. And these license plaques were the most frequently for this parking lot. If we throw at this dashboard, we can see the information of each of parking lot under this study. And finally, here we can see some conclusion of our work. We mentioned that conclusion through all the presentation. For the 30 parking lots under study, the highest occupancy was in 2020, and the lowest occupancy was in 2021. And we can see the impact of COVID-19 only in 2021. September had more occupancy than October. The longest duration in minutes were lot number 8 and lot number 82, and we can give some incentives to the users more frequent in that parking lots. And here we can see some reference of our work. Okay, that is all. Thank you very much.
All right, thank you for that presentation, Group 34, GC34. Sharon, you have a question?
Yep. Great presentation. I really liked how you enriched your data using external data sets, like you brought external data set. Can you speak a little bit to, like, what was your experience? Like, how did you merge the external data set into your data that you had?
Yeah, that was a very tough area. I mean, it was like for me, corresponds to what is called ETL, like extract, transform, and load. First of all, we had in mind about the distances of the top closest, and as I have mentioned, was I used Google Maps library from Python using some queries, which are very expensive, by the way, in terms of money. We're using Google Maps API, and then we combined. Then we got this survey from the Transport Tomorrow survey. We decided to use the most recent one, and one of the problems was to put all the parking lots in each ward.
Yeah.
And because there is no there is no a map that can give you that information. So, for example, this kind of, and there were 400 variables, but after cleaning it, there were 224. And then we extracted from your data set this kind of useful information, like price per hour, and total numbers of open hours, and day of month, and so on. Everything was used using Python. And so we finally construct the matrix of features, and the target always was the occupancy. Actually, we made the occupancy by each 50 minutes, but our final results using machine learning algorithms was for just per day. And about that, it's important to mention that, for example, if you consider, if you put the total duration, this variable, the duration that we get, and if you sum all of the durations of the cars which were parked, we call this variable as the total duration. if you put it on the algorithm, you get like 0.9, which is very close to 1, which would be like a top, very accurate predictive algorithm. But this is considered like, this variable is considered like a data leakage, because you cannot, this information is not given in advance. You cannot use it in a real scenario.
That is correct. Yeah. No.
Yeah.
Thank you. Thanks for the detailed explanation. Thank you.
Yeah, you're welcome.
Oh,
Yeah, so I don't have a question. I just wanted to kind of give a few comments on what I thought was a really great presentation. I just want to say I really liked how you guys started with the machine learning aspect of it, but didn't get stuck down the machine learning rabbit hole on trying to like refine a model and trying to find the perfect variables. You guys kind of just went at it and said, here's the things that we know are impacting it. Now let's dive deeper into that and try to understand how we can apply that data to all the lots that were asked of you guys. And I think you did a really great job of that. And I think, you know, putting it into Power BI as well was a really great move as well, because like you're going to have someone who's going to have a lot of questions on like, oh, well, what if it's this lot? What if it's this lot? What if it's that lot? And just having something a little bit interactive, I think takes a lot of work. And I can tell you guys put a lot of work into this. So I just wanted to say great job. And I was really, really impressed with your approach.
Thank you. Thank you very much.
Vivek.
I will agree with Paul. Great presentation, lots of hard work, what you have done. And also you have used one of the tools that I really love, Power BI, because I'm one of the biggest contributor from Microsoft side on designing Power BI. So great tool. I'm not biased, really hard work, very like a good presentation. And you can take it to the next level. I think you have all the data. City of Hamilton can definitely use that to explore other parking lots also. And this is not a venue, but I would like to invite to one of my presentation. I run a user group in Toronto, so I really love the analysis you have done, and I would like to invite you guys for presentation.
Thank you.
Really, I appreciate it. Thank you very much.
Juliana.
I don't have any questions. I just want to say again, like how in love I am with the dashboard that you created. It's even better to see you guys interact with it. It's just wonderful. And like it just has such obvious real world utility. And I think that you guys did an amazing amount of work. And thank you so much.
Thank you for organize this event. I really enjoy it. So thank you very much, all of you.
Well, if there's one thing you've taught us with this presentation is how nice it is to have that interactive presentation using the Power BI or other tools where you can demonstrate the interactivity with the data right during the presentation. There's a lot of power to that. And I'm just going to echo the judge's comments. Fantastic job and great work. That's going to wrap up this presentation. So that was group GC34. And we will now be moving on to the final presentation of the day. And that is going to be starting off in room number 7 shortly. Hope to see you all there. Thanks so much, everybody.
Thank you.
Thank you.
Bye-bye.
Thank you very much.